Chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. Causality is part of the Engineered Network. To support our shows, including this one, head over to our Patreon page, and for other great shows, visit engineered.network today. The Sampoong Department Store. So much to build, and so little time. On the 29th of June 1995 in Seoul, Korea, the Sampoong Department Store would collapse and become the largest peacetime disaster in the history of South Korea. And also, until the World Trade Tower collapses on the 11th of September, it was the largest modern building collapse at that time. South Korea had experienced a huge boom in the economy in the prior decade, and that drove a large construction boom to meet that demand. The building in question began construction in 1987, in a particularly busy time with the Seoul Olympics just around the corner the next year, and it was open to the public on the 7th of July, 1990. The building was home to about 1,000 staff and saw an average of 40,000 customers pass through its doors every single day, with nearly 8 acres of retail floor space. At the time, it was the 7th largest store in South Korea, with a turnover of $500,000 every single day. The building had 4 basement levels and 5 levels above the ground, with the majority of the floors from the first basement to the 4th floor being retail space. The 5th floor had restaurants. At 8 a.m. in the morning, the building facility manager, John Chidgey, inspected the roof in response to a note that had been left on his desk by the night security guard reporting strange noises coming from the upper floors during the night. The cracks in the rooftop that he saw had in fact been there for several years, since the air conditioners were moved, and he returned downstairs observing nothing different from his previous visual inspections. By 10 a.m., he had moved down into the restaurants and responded to a report from the Chunwan restaurant, where a crack had formed around support column number 5E, where it joined with the floor. The column had physically begun to sink downward at the point of the crack, and the crack was fully around the base of the column. Shortly after this, the decision was made to close that restaurant. No other advice was provided to others in the building beyond that restaurant affected. At 12:30 p.m., reports came in from the 5th floor of audible vibrations, and suspecting that the air conditioners were causing it, they were then shut off for the entire building at that stage. Shoppers in the store were informed by building management that the air conditioning would be off for the remainder of the day due to a fault. It wasn't ideal, considering it was the middle of summer in South Korea at that time. By 4 p.m. that afternoon, the cracks in the restaurant had widened to 4 inches from the column, and the customers still in the store were now complaining about the lack of air conditioning, and many had left. A meeting was held at this time between John Chidgey, the store owner Lee Jun, and structural engineer Hok Soo Lee. And despite the structural engineer's suggestion to close the building and evacuate it immediately, Lee Jun rejected the suggestion and insisted the shopping day close at normal hours. In addition, they ordered that the cracks be filled with a gap filler and any merchandise in the immediate area be moved to a storage area in one of the basement levels. The executives and engineer left the building following this meeting. By 5 p.m., the facility manager was being regularly approached by staff on the 5th floor. More vibrations began to be felt, despite the air conditioning having been turned off since lunchtime. At 5:40 p.m., the first of a series of loud bangs was heard on the 5th floor, and the ceiling began to visibly sag around column 5E. At 5:52 and 30 seconds, with the air temperature in the building now at 32 degrees Celsius or 90 degrees Fahrenheit, and with 1,500 people still in the building, the entire building experienced a strong rumbling vibration emanating through the entire structure. Alarms began to sound as fixtures and fittings began to fall from the walls and ceilings in scenes similar to that of an earthquake hitting. Shoppers and staff immediately rushed towards the nearest exits that they could find, but few were able to escape the structure in time. The building collapsed from the top floor down, and by 5:52 and 50 seconds, only 20 seconds later, the building had almost entirely disintegrated. In that 20 seconds, scarcely anyone was able to escape. The only remaining standing section of the building was the end facade, and the entire southern wing was destroyed. Up to 30 cranes and excavators were brought in to remove the rubble as carefully as possible to attempt to rescue as many as they could. After the second day, the remaining northern end of the building was showing signs of instability, and work with heavy machinery in the rescue effort appeared to be putting the rescuers at risk. The rescue teams were told to stop, sparking large-scale street protests and riots. On the third day, structural engineers rigged high-tensile steel cables to the remaining structure to prevent it from falling, and rescue attempts recommenced. This went on for nearly 3 weeks, with the final survivor being pulled from the debris, 19-year-old Park Sung-hyun, after a staggering 16 days being trapped in total darkness. She had survived by drinking rainwater that had been draining through the cracks in the debris. In total, 937 people were seriously injured, and 502 people died. When a structure fails, the options from a civil engineering perspective are a design flaw. No matter how well constructed or maintained, a flaw would always be present. A construction flaw, correctly designed but incorrectly specified, or selected construction materials were used, or in the case of concrete, it was prepared or poured incorrectly. And the third option is a post-construction flaw. The design was modified post-construction and did not respect the design limits of the structure. The building design was what's referred to as a flat slab construction. It's one of the most common methods of building multi-story buildings. Steel-reinforced concrete support columns are poured, then formwork is held in place while the floor slab is poured. And once that's set, the columns are then built higher, ready for the next floor. The next floor is poured, and so on, with each respective floor, and the building rises above the ground. Each floor slab has its weight supported entirely by the columns. And there are two key variables: the size of the columns and the spacing between those columns. The more columns that you have for a given floor area, the smaller the spans between the columns are, and therefore the more distributed the load is. The smaller the columns, therefore, you can have. And that works well for office buildings, where they have many corridors, offices, and cubicles. However, for department stores, the open visible retail space is a competing requirement with this. The job of a civil structural engineer is to determine the load-bearing capacity of the columns and the required slab thickness to ensure that the load is spread correctly and the structure will be stable. In addition, most calculations assume a derating factor of between 2 to 2.5 times the actual load-bearing requirements in the design stage. Better over-designed and structurally stronger than to risk a collapse. During construction, inspections are required to ensure the building formwork and concrete consistency is compliant with that specified in the design. Once it's completed, regular building inspections were and remain a government requirement to ensure that any signs of potential failures are identified and addressed before incidents can occur, and ensure that continued safety and compliance of the structure in question. This specific building had passed its most recent regular building safety inspection only a few weeks prior to this incident. Interesting. The investigation was led by Professor Lan Chung from the Dankook University Engineering Department. Early theories about the trigger of the collapse related to gas explosions and terrorist bombs, as both had occurred in South Korea in recent times. However, it quickly became clear that neither of these were the case. The debris field from either an explosion or from gas or a terrorist bomb would have sent debris laterally away from the core of the building structure. However, in this instance, the building effectively collapsed entirely onto itself, with minimal spillage of debris over the area immediately surrounding the building. In that respect, it had far more common with a precise building detonation as a planned demolition rather than anything else. The investigation reviewed the civil structural design drawings and the structural engineer's load-bearing calculations and found multiple discrepancies. The original column designs were calculated as requiring an 800 millimeters diameter, but the drawings showed that they were only to be constructed with a 600 millimeter diameter. This was confirmed as built by inspecting the wreckage. Further inspection of the wreckage found that the steel reinforcing should have been 50 millimeters from the top of the floor slab per the design, but they were in fact 100 millimeters from the top of the slab. This has the effect of reducing the strength of that slab by approximately 1/5 overall. In addition, the design called for 16 reinforcing bars to be installed for each horizontal slab segment, but only 8 were physically present when the debris was examined. The building was originally designed to only have 4 floors above the ground, and was originally supposed to have been an office complex. However, when it was halfway through the construction, the owners changed the requirements to become a department store and insisted that an additional floor be added for a skating rink, and several columns needed to be removed from the building to allow for escalators to be fitted between the floors. Obviously, an office building would favor internal staircases and lifts or elevators rather than escalators. The construction company at the time, Woosung Construction, refused to the owners and said they would not make those modifications. They were subsequently sacked by the owners, and Lee Jun utilized his own construction company to complete the works with the new additions that they wanted. Part of the problem was finding a construction company at the time, with the rush of other construction jobs, the economic boom, and the imminent Olympics. In the years leading up to this, the government had enforced a rule that no overseas construction companies could sign off on construction contracts as a way of ensuring local contractors were protected by international competition. This forced the entire construction workload within the country to be handled by South Korean constructors only. They were already stretched thin at the time and were stretched even thinner immediately prior to the Olympics, with many corners cut and deals made to simply get the job done by the required deadlines imposed by owners. As construction of the 5th floor began, the owners changed their minds yet again and decided that instead of a skating rink, they would instead fit out a space for 8 restaurants. In Korea, diners typically dine seated at floor level. This seems fine for traditional structures made with wooden floors. However, concrete slab construction, the slab is usually quite cold, and hence heating tubes are required to be embedded in the slab to keep seating areas warm and comfortable for restaurant patrons. This requires a thicker slab to accommodate that heating system, and the 5th floor slab and restaurant equipment additionally added more weight to the slab, although the columns remained the same, already undersized diameter. In total, the 5th floor slab gained an additional 900 millimeters, that's 3 feet, of slab thickness in order to accommodate the heaters, heating tubes, additional cooling water weight also added more to the existing levels underneath. Worse again, the restaurant layout that the owners desired was fundamentally incompatible with the other floor's column positions, and the design modifications required that the 5th floor support columns also be moved. This meant that the 5th floor columns didn't all align with those columns from the floors beneath. The columns therefore didn't vertically align from top to bottom in the building, and the load from the very rooftop slab and the 5th floor columns were predominantly supported by the 4th floor ceiling slab that was originally intended to be the rooftop slab prior to the design change. To determine the concrete quality, the investigators determined by testing samples from the rubble that the concrete strength used varied between 18.4 megapascals and 19.3 megapascals, rather than the design specified higher 21 megapascals. Despite all of these things, underspec concrete, excessive weight of the 5th floor slab, misaligned columns on the 5th floor, Even when fully loaded with equipment, floor stock, and people, the building had just enough margin left in its stripped-back design and poor construction that it remained standing for 6 years. So where did it go wrong? The construction was very close to the edge of stability, but something had to push it over the line, the final straw as it were. And the answer the investigators found was quite surprising. After the building had been operational for several years, apartment buildings on the eastern side of the building had neighbours raising multiple complaints during 1992 and 1993 about the loud air conditioning units on the roof of Sampoong. To address their concerns, the owners of the building moved the air conditioning units from their original position to one further away on the opposite side of the rooftop. When the air conditioning units were moved, however, they did not use cranes to lift and reposition them, as per when they were installed originally, but instead opted to use their original delivery skid as a sled and used rollers arranged beneath and dragged them across the roof to their new position. Each ACU weighed 15 tons each, and the roof was designed to handle their static load, let alone a dynamic load, moving them across it, as though the slab on the rooftop was a roadway. Moving each unit introduced cracks across the entire rooftop slab. Some were visible, others weren't. But the ones made nearest the support column positions, and in particular column 5E, would ultimately be that final straw for the building years later. Even in their new positions on the rooftop, the air conditioning units still created vibration, particularly during their ramp up on starting and cool down on stopping cycles. Every day, for the 2 years after the ACUs were moved, the vibrations they created pushed these cracks further and further through the concrete until the 29th of June, when the column finally separated from the slab under the load at column 5E. As the ceiling at 5E column began to sag, with no support from the column anymore, the steel stretched slowly during the day, creating new cracks on the rooftop slab segment. Each new crack weakened the slab at those points, allowing the sag to droop further, and this progressed nearly imperceptibly during the day as it progressed, until several larger movements approaching 5:30 p.m. signaled that collapse was imminent. The first slab section of the rooftop crumbled under the weight of the air conditioning units. Its collapse onto the slab beneath presented a large, dynamic, instantaneous load to that slab, which was already stressed to near its load limit. And that caused the fourth floor slab to buckle. And when it collapsed, it caused the next level to buckle, and so on. And in just 20 seconds, it was all over. At 9.81 meters per second, over a height of about 25 meters, it doesn't take long for a building to fall. And what can only be described as a despicable act. There were many cases of looting of valuable merchandise and the cash register contents following the collapse, just before the emergency crews arrived. None of the looters were ever apprehended. Beyond the staggering loss of life, the estimated property damage was about $216 million US. Professor Chung and the investigation team found that the collapse was caused by human ignorance, negligence, and greed, and due to the illegal alteration of the architectural design and subsequent usage of the building. Lee Jun was jailed on the 27th of December 1995 for 10.5 years for criminal negligence. His sentence was reduced to 7 years on appeal in April the following year. However, on the 4th of October 2003, only a few days after his release from prison, Lee Jun died of natural causes related to ongoing high blood pressure and diabetes. His son, Lee Han-sang, the store president and CEO, was jailed for 7 years for corruption and accidental homicide. Widespread corruption as a result of the investigation was found, and further investigations surrounding Sampoong had a further 21 people found guilty and jailed, including 12 government officials. In particular, Lee Chung-woo and Hwang Chol-min were found to have been bribed into concealing the construction modifications against building codes. The former Lee family business conglomerate was stripped of all of their possessions and assets, to cover the settlement costs of $350 million US. This resulted in the complete dissolution of the Sampoong Group. Following the collapse and the removal of the corrupt officials, finally, truly independent civil structural engineering inspections of all multi-story buildings in South Korea found that an average of 1 in every 7 buildings in that construction period needed to be completely rebuilt as they were dangerously unsafe. 4 out of every 5 buildings inspected needed retrofitting to bring them up to current construction codes and standards. If you run those numbers, you reach a most amazing fact that only 1 in every 50 buildings was assessed as being built to standards and safe to occupy. That's 2%. Just 2% were safe. Despite protests by family members and from the victims of the tragedy to respect the site and build a memorial for their loved ones, a luxury apartment complex called the Accra Vista Apartments was completed in 2004 on the site of the Sampoong Department Store collapse. Ultimately, the root cause isn't what you might think, at least not at first. It's easy to blame the constructors and the owners, but if you really pare it back to look at the true root cause, where did it start to go wrong for those 98% of buildings constructed at that time? The true failure that caused all of this was caused by 2 things. The first, the construction boom due to a growing economy and the impending Olympics. Second, government regulations that protected the local construction industry had kept outside expertise and manpower out of the local industry, whilst simultaneously leaving what little expertise that was available in the local South Korean market stretched far, far too thin. In short, the government attempted to protect their local economy at a time when construction demand meant there could be only one outcome. Woosung Constructions did the right thing. They rejected the changes. They were responsible engineers and did the right thing. Things actually fell apart when Lee Jung took over, forced out the competent constructors, and pushed their own agenda. Knowing officials were run off their feet with demand and lacking sufficient local expertise, they did what they felt like and broke basic engineering design rules, and the government didn't stop them. I learned very early in my career the difference between a surface crack on a poorly treated slab post-pour and structural cracking. It's clear to me that any competent civil engineer doing a regular structural inspection would have known the cracks on the rooftop were structural. And they would have known for at least a year, probably 2 years, since the air conditioning units were moved. Clearly, the government-appointed building inspectors were either bribed or just incompetent. Worse than that was the complicit denial of the executives and many of the store staff on the day of the incident. They just carried on business as usual, pretending nothing was wrong, perhaps knowing no better. But they could have evacuated the store on the advice of the structural engineer, even as late as 5:30 p.m., and cleared the building within 20 minutes. With minimal injury, perhaps even then no one would have died. Clear it once you hear cracking noises. Do you think you might want to do that? Would that make sense? Buildings don't make those sorts of noises. That's not normal. The perspective of most people with a building is that it's taken for granted. It's solid, it's stable, it doesn't move. It's just not going to fall. From the perspective of a civil engineer, that structure is constantly fighting gravity to stay up. When they look at a building with a critical eye, they're asking the question, is this going to fall? And if so, how is it going to fall? With the aim of determining if it's actually a safe structure to be in. And although it's not always true, the right people were brought to justice in this case. I know that's small consolation for the families of those that were lost, but I do wonder about that second construction team. They can't all have been incompetent. Surely one of them knew that they were cutting the wrong corners, that they were doing bad engineering design, that they weren't revisiting the calculations to determine the correct load-bearing requirements. Surely one of them could have stopped this, said something, done something. It must have taken a large number of people involved being bullied, harassed, bribed, and blindly doing as they were told without question to create this incomprehensibly insane incident. Regulations and building codes exist for a reason, and they're based on hundreds, if not thousands, of years of collective human structural design experience. And these days, in addition, modern chemistry and physics as well. For goodness sake, pay attention to them. And if you ever see anything wrong, flag it and don't ignore it. Warn people, make noise, don't be bullied or bribed into silence. And if you're ever in a building making noises like that, my best advice, just get out and get as many people to follow you out as you can. If you're enjoying Causality and you want to support the show, you can, like some of our backers, Ivan, Daniel Dudley, and Chris Stone. They and many others are patrons of the show via Patreon, and you can find it at patreon.com/John Chidgey, all one word. So if you'd like to contribute something, anything at all, it's very much appreciated. This was Causality. I'm John Chidgey. Thanks for listening.